let it possess a charge. Let this be the point P. So what is the potential? Potential at point P. We write KQ by R or Q by 4 pi epsilon R. And according to definition, V equal to Q by C. So equating this, Vp by Q should be equal to C equal to how much it should be? So what is telling? The capacitance of a conductor depends on what? It just depends upon its physical dimensions. This will be really troublesome for you. Sir, how come? Similarly, the resistance will it depends on how much of current flows? No, it depends upon the physical parameter, the same thing. So you treat this capacitance similar to bucket, where all capacitor there. No, just imagine bucket. Your problem will be solved. Bucket or capacitor, both are same. What capacitor will do? Bucket. First we'll analyze. What is a bucket? Why do we use bucket? I think in bathroom, bucket to store water. So bucket, what is the purpose? Used to store water. So what is a capacitor in electrical circuits? Used to store charge. So therefore, the analogy, this will be best way of really understanding problems. So when you're doing numericals, no, really this approach will help you a lot. Then, sir, okay, bucket, okay, charge and water, you brought it. What is about the capacitance? Capacitance of bucket 10 liter depends on what? Depends on the height, the radius, area of cross section. It'll be like this, no? L and A like this. The capacitance of bucket depends on what? Volume, the dimensions. Similarly, the capacitance of spherical conductor depends on its radius. The capacity 10 liter bucket, it depends upon its height and the length and the area of cross section radius. Similarly, the capacitance of conductor, spherical conductor, depends on its radius. Okay, like this, what happens? The physical dimensions will determine how much of capacitance. Then, what about the potential one? How do we go for potential? So we are going to store water. We are going to store water. So this is the water. No, I need not to fully fill up water. I need not to fully fill up water. So the water will be filled up to height h. Same thing here. I can store in this particular spherical conductor a charge fully or less than the maximum value. Because what is the maximum capacity of this bucket? So say 10 liter means 10 liter I can store. Can I store 5 liter? Yes, it will permit, no. Or bucket will say only you can store 10 liter, no. Anything 0 to 10 liter, the same thing. This particular conductor is also having some capacity. And from that capacity open, you can store some amount of charge. And you can store any charge between 0 to that Q max. Who will determine that Q max? Depends upon the capacitance. Okay, got this? So now what is the potential here? What to define? So we say potential of capacitor. Here, the height will refer for potential. Charge is used for this. So here, potential, what we have is the other thing. Potential, it is analogy to potential of height of water. I think it's very clear in front of you now. It's quite very clear for you now. You can see that more capacitance, 20 liter can store more water, 20 liter, 10 liter bucket, capacity 10 liter, it can store anywhere between 0 to 10 liter. So therefore, greater the capacity, more amount of water it can store. So therefore, charge is directly proportional to capacitance. Then next again, more the water is, more the height. As the amount of water increases, what happens to level? Level will increase. Similarly, as the amount of charge increases, the potential also will increase. Are you trying to? I'm just trying to correlate here. At the level of water increases. So therefore, what you say that at the amount of water increases, the level will increase here. Similarly here, And the amount of charge increases, the potential increase. So like that, the level of water will be similar to like a potential. Why I'm telling this one is because we do have problems where if you can think like this, it'll be very easy for you. Solving problems will be very easy because we do get very good conceptual questions. So just you should add up this one. And now already is having some water. Can I add more water? Yes. Similarly, already is having a charge Q. Can I add more amount of charge? Yes. Is there any maximum permitted limit of charge? Yes. Is the maximum permitted limit of water in bucket? Yes. 10-liter bucket, if the capacity 10 liter, yes, there's some amount of water you can add. The upper limit. Same thing happens for capacitor also. Clear this? So there's some upper limit of charge what you can store. What happens if you pour water more than the capacity? 10 liters capacity, you pour 11 liter. 10 liter will be there, the remaining 1 liter will overflow. What happens to capacitor here? It's having some upper limit of charge. When you put charge more than that, here it will burn out. Here you can say tank will burst out, the bucket will burst out. Here what happens? The capacitor will burn out. Like this, all things will be correlated. So I brought an equation for like this. The next question comes, to add particular charge means we'll go for energy of this one, because shall I say bucket, it contains now the energy in what form? Potential energy. Similarly, what all we put charge here, the charge will be available as electrostatic energy, that one. So let me calculate the energy of a capacitor. I'm introducing to the next concept, energy of a capacitor. So there's a conductor. So initially it was neutral. Now I'll add a charge dq to it. Then it will acquire like this continuously. I'll add a charge dq. Now it has acquired a charge q, then dq, and finally what happened? It has acquired a charge of q. So how much of work I'll be doing for this? This is an iron sphere. So let's go for, so there's a point on a conductor. So work done by external agent in moving a charge from infinity to point P on a surface of conductor. The charge dq should be Vp minus V infinity. This is what? du or dw, you write time being. This is equal to dq, potential Vp. And this should be equal to dq, potential on the surface of conductor, kq by r. So this should be dw equal to kr q dq. What all I do work, what will happen to it? It will be available in the charge system. So finally, how much of charge? It was earlier, it was 0. Finally, it is acquired. There's a final, no? And there's a initial. So 0 to q. So k q square by 2r. So let's do one thing. What is value of k? 1 by 4 pi epsilon naught r q square by 2. What is 4 pi epsilon naught? What all work done by X-ray agent? This will be available as electrostatic potential energy. Q square by 4 pi epsilon naught, what you can write? C. So therefore, the energy in capacitor depends on what? Charge by capacitance. Now, what are the other forms you can